Thank you for joining us today. We are here for another edition of Technomatic's Virtual User Group for our community conversations. My name is Taryn Blake. I'm the Community Engagement Program Manager for Siemens PLM software, and I'll be your host for this enablement session. Today's topic is worker batch processing with load-unload control. Now, as many of you know, our speaker for today is Mr. Steffen Bangsow, who is a freelance simulation expert with years of experience. He's done hundreds of projects and training sessions, and Steffen has 5 books actually on plant simulation. He does have one more in the works, and he is one of our leading contributors to the Siemens PLM community and also a community catalyst here at Siemens. So for today, the big steps or areas that he will be taking us through are configuring and unloading boxes, loading and unloading machines using worker controls, loading parts into boxes as part of batch logic, and then transporting finished boxes through the system. So as we mentioned, Steffen always presents live, and then we'll also do live Q&A afterwards via hand raise. So that is it for my introduction. Steffen, feel free to steal the screen.
Hello again for our next session. And today's session is about quite a standard case. If you have a worker and the worker needs to load parts from a box and process the part on a station and then puts the part in another box, and after the box is empty, he needs to move the filled box to the next station and the empty box to the other buffer. And you will need a lot of programming to do this. And in this case today, I want to show you the programming using the new functionalities of unload and load controls in the workplaces. And in this case, we can use the broker, we can mediate the worker, and so we have a clean statistics. And if you need another worker in this case, then the worker can change. This has a lot of advantages. But first, I want to create a little example for this. I want to have a source. The source needs to create filled boxes. I have a buffer. This I name buffer in. Then I have a station, a buffer out. Then the next buffer, I call it buffer N. And one train. Very simple model here. In the first step, I need, of course, a broker, because I want to use the default mediation of the worker, and I need a worker pool. And of course, I need a lot of workplaces. I need a workplace here. I activate the transport importer already. I need one here. I need one here for unloading the filled boxes. I need to activate a lot of importers. I need the importer from buffer in to station. So I check if this is active. Okay, transport importer is active here. I need a transport importer and the importer for processing on the station. So I need the importer for processing, and I need the importer for transport, and the MU target is buffer out. I need here a transport importer, and destination is buffer N. And I need one successor of the train of the source. Okay, on this buffer out, I need an empty box at the start of the simulation, and this I create with init method. So I insert one init method in my frame, and I use all the basic MUs from the class library. And I want to create a container. And I want to create filled boxes here in my source. And the box has a capacity of 4. And I can do this here in the entrance control of the source. I create one entrance control, and while at full is false, I create parts until the box is full. You can also use one assembly station to do this, or like here with 3 lines of SimTalk. Okay, this is the basic model, and now the model is doing something, but okay, I create parts now. It's not right. I need to create containers here in my source. Okay, now first my worker puts the empty box here from buffer out and buffer in, but he should only move the box if the box is full. And to avoid this automatic transport, I need to define an exit control here. And capacity should be 1. Also here it's only capacity of 1. I need exit control. I need to wait until the box is full, and then I can transport the box. and this will prevent the movement of the empty box. So that's fine. Here in this buffer, I don't have select a destination for the MU. If I define in the importer here the MU target station, then my worker will come and load the complete box into the station. And this behavior is wrong. Instead, I need to load one part out of the box and transport it to the station. And to do this, we need to adjust the basic behavior of the worker a little bit. And for this reason, we have now since 2404, I guess, there are some new methods here that we can define in the workplaces. And this is load and unload control. And with this control, we can adjust a little bit the basic behavior of the worker. The basic behavior of the worker would be to grab the complete box, but we want to load one part out of the box. And just as an example, to do this, I need a load control. It makes a lot of stuff here. I don't want to have this. So I delete all this thing. We can access the box here with bufferin.cont and one part out of the box with bufferin.cont. But we need to set a destination for this movement, otherwise we get an error message. And so we need to address the part by setting the destination attribute to station. Let's have a try. Now he gets only one part. And then we have a little problem here because we have to set some settings here in the importer. Wait for free targets, a problem. The same here. In the transport importer, we need to deactivate wait for free target. Otherwise, we don't get this to run. So if we want to load more than one part out of the box, we need to write some exit control here. Because if we have once triggered the exit of the buffer, then it creates one transport order for the worker, but then not for the other parts automatically. And so we need to create some control to load all the parts here from the box, and then the box itself should trigger the transport by the worker. And so we need to write an exit control in the buffer here. Finally, we need to move the box. we can use a loop for the first step. A loop that is running until the box is empty, or as long as the box is occupied. We need to move all the parts out of the box. And first I read the number of parts inside the box. Buffer int cont or question mark quant is here the box, and number mu, the number of parts inside of the box. Then I wait until the station is empty. And then I move the part. And this will trigger the transport importer. And I need to wait until the part was moved from the box for the next loop inside this, for the next, for next loop. And this I can do by looking in the box how many parts inside, and if this is lower than the old number I have read here, then the box, the part is moved. You also can control the part itself. And then as a next security, I wait 10 seconds not to create too much orders at the same time. And then I move the container. If this is empty, this box, then I move the container itself. First, I need to move the full container, and so I wait until the buffer out is not occupied anymore, and then I start to move this box here. Okay, so I need to change a little bit here the basic behavior. I don't want to move the container before it's empty, and so I need to move each single part out of the container. And the same behavior, the same kind of control you need if you, for instance, want to unload a box with a robot. It's quite the same here. Okay, this should work. So it's now processing one part. But then we have a problem. He transported parts to the next station, but then he wants to unload the part directly on buffer out, and not he doesn't understand that there is a container and this content should move on the container. And so again, we need to adjust a little bit the basic behavior of this worker, how he unload the part. And this we can do again with the unload control of the workplace. Controls, unload, I make a new control. I don't need all this stuff here. And we have two cases here for this scenario. One case is he unloads, he comes with a part and the buffer out is occupied. Then we need to move the part to the container. And the second case is buffer out is empty and he comes with the box, and then he need to unload the box here directly. And so we have two cases. So if buffer out is occupied, then that is the worker here in this case. Cont, the part he is carrying, but move. And the container, it's quite the same. The only difference is I don't move the part, the container to buffer.cont. I move the container directly to buffer out. Okay. Let's have a try. So now I get an error message here because I need a second case here. Now my box here is not occupied anymore, and so I cannot set a destination to cont, and I get the error message avoid cannot accept the method destination. And so I need two cases here. One case is the container is occupied, and the second one, the container is not occupied. And in the case the container is empty, we also need to set another destination. We need to set buffer out as a destination. And this we can do here very easily. We can also distribute all the parts to different destinations using this load control. And so I just so I need two cases here. One case if buffer in cont this is the case we need to transport a part. As we need to transport the container. And it's quite the same here. It's only really to delete one cont here. The destination is buffer out. And then I need to load the container itself. And from the beginning. Okay. This is one big advantage. If you use the unload and load control, you can easily parameterize this for a lot of different workplaces and stations. And you have a lot of functions here that are running with the default settings. For instance, here the importer, processing, transport. We don't have here any programming. We don't need to program here something. And the same is from buffer out to buffer in. We don't need to program this behavior because it's quite the basic transport importer stuff that is running here. We don't need to program. We only need to adjust a little bit the behavior of the worker by loading and unloading the parts. And at the end, you have a clean okay, take the chart here. What correlation table. So at the end, we have also a clean chart. We don't need to create our own charts because we're using only the basic behavior of the worker. And if you try to solve this stuff with SimTalk, you need to make your own statistics. And this is easier, cleaner, leaner. And I have another use case. You can find this as a video in the webinars. I have used this unload load control to synchronize the worker with the crane. And this is also possible because you can split up the basic behavior of the worker. You can, if the worker has to unload something, then this unload control is triggered when the worker reaches the workplace. And then you can control the worker by yourself until the worker has unloaded the part he is carrying. And so you can create a complete new behavior of the worker. Okay.
And while people are thinking about questions, if you've been here with us for a while, you know there are always announcements. The main one is that the recording, if you weren't here with us at the beginning, will be available at the link on your screen on Friday. You can click that link. It is live And the image that you see is showing our plant simulation virtual user group forum. And we recommend that you follow the topic, which you can do by clicking the button there, and then going to the envelope icon on that button to select the email notifications for every post. And this is because the only thing posted and that link are invitations to our live sessions, so registration links, and then on-demand videos, so recordings of the videos, and occasional questions about the content in the videos. So it's a good thing to select every post. You'll get a system email as soon as there's an update to this area in our forums. And then you also can see our next meeting. So those links are also live. You can click through April 8th. Steffen will be with us talking about creating Gantt charts and using the data table. And we'll take a 2-week break and come back on Wednesday, April 29th, where Steffen will lead us through creating chain conveyors with dynamic transporters. So that is the next topics. And then it looks like we do have a couple of questions in the chat, so I'll get through these couple of announcements. So this is just the Siemens Accelerator Academy. If you haven't seen this before, you can click on those areas. They wanted us to let you know that there are comprehensive education courses for plant simulation. There's even a certification, associate certificate. You can click through there to learn more about those. And then this one is really close to my heart, is a reminder that Realize Live is happening this summer, as it does every summer. This is the in-person customer event for Siemens PLM software users. And this occurs in the Americas, this year in Detroit, in Europe, this year in Amsterdam, and in APAC. Typically India, and that will be in Bangsow, if I'm saying that correctly. So again, click the links there to learn more about this. I'll be there, Steffen will be there. Most of our community catalysts are attending this year at one location or another.
Okay, I take the screen.
Thank you.
I use the load-unload controls often. I find them really helpful. This may not be related to programming the controls, but how would you capture the worker opening a new box before transporting the 4 parts? Suppose the worker has to use a box cutter, remove plastic wrap before accessing the parts. Yes, I never had tested this, but you can use the load control also to move the worker, and so you can wait and can I don't know if you can load another part, but you can let the worker work with GoTo and unload and place the plastics, but I just would only to let them wait there. But you need to look on which statistical value this has some impact. And normally is en route to job. Here, if you have the chart, this will increase this en route to job element. And if you need a separate value for this here for unboxing, then you need to record the value for yourself. Otherwise, this will only to create a larger en route to job value. Yes, but you can just let them wait for the first time, for the first part, if the box is full, for instance. Can entry-exit controls be used instead of load-unload at workstation? You can use the entry control. It's the same time, but you need to check the basic behavior of the worker. Normally, he tries to unload the part directly to the station. You cannot stop this behavior. You can stop this behavior by unconnect the workplace from the station, so that you run to the station, and then you can trigger the entrance control, and then you can program the unloading. Loading difficult because he tries to load directly, and the exit control of the workplace will be triggered if he left the workplace, so it's useless for us. But it's really easier with this load unload control, because the job keeps unfinished until you load or unload the part, and this is quite helpful.
That's good.
How you would success creating a different worker statistic instead of being captured in en route to job. Just record it in a user-defined attribute, but you cannot use the automatic worker statistics. Then you need to create your own statistics. You find all the values here in the worker in his attributes, and then make a second one, and then you need to subtract this stat unpacking time from this stat en route to job time, and then create statistics from this. Shift calendar greatly influences the logic of the workers to try to modify standard behavior, for example, finish processing task or carry a task before leaving for break or shift end. Another example, load unloading times are not obeyed if shift break happens during operation. It's a problem, yes. I have a lot of projects with very long processing times, and there are much more problems. For instance, if you have set up processes and you need to finish the setup independent from the shift calendar. Yes, and in this case, you cannot use the shift calendar directly, because it influences directly the worker behavior, and so you need to make it independent from the worker, for instance, with a dummy station, and that the worker checks the remaining time for a certain job, or checks the state of the dummy station, and then you can send them with set pause in, for instance, into the pause if he has to finish his job, but you cannot directly attach the shift calendar to the worker pool or the worker. You need to make it indirectly. I don't know another way. Yeah, the same as with load, unload, and time. There are some overlapping stuff here in plant simulation that you need to take into account if you have pause and failure, unloading time, and doing the if then starting the pause. There are some fuzzy gray areas where the data does not fit into 100% at the end. Yes.
Yeah, we got a thank you in the chat, which is lovely. We're definitely finished with time for more questions. If anyone has a general question about plant simulation or the series, that's always an option too while we have time.
Yes. And if you have ideas for topics, new ideas are welcome at every time.
That would be here. You can see the link to the virtual user group, but it looks like it's quite a few of our regular attendees in the chat there. It's always fun to see familiar names. I guess we'll see everyone in the forums.
Goodbye.
Thanks, everyone. Bye-bye.